Okay, we will now compare the mass of the solid shaft to the hollow shaft, and to say, here you see this, they are the same length is same when they are made up of the same material. So suppose if you actually look at the equation of the torsion, if I look at the torsion equation, the torsion equation says T by, so tera towel, ganda theta, jaldi rin lagao, something like this, no? So we are not worried about this part of the equation. So G theta by L is not, I think we actually don't have to worry about it, okay? Of course length is given, but no issues, now for the same length. Now, here they are saying, now it is for the same material. So same material means they have got same shear stress. So that means they can take maximum shear stress same. Suppose if it is made up of steel, it may take around shear stress of around 200 or 150 or 100. So therefore they will take the same shear stress. And it is said that they have to transmit the same power at same speed. Same power at same speed means, so we know P is equal to 2 pi nt by 60. Same n and same power means T is also same. So torque applied on this is also same. So therefore we are supposed to find out this ms by mh, and before that we are now supposed to understand that since they are made up of the same material, so let us make an equation something like this. So we will try to shift this equation. So something like this. So the shear stress tau is equal to T into R divided by Jp. So this is the stress, it is the shear stress in the material, and it is the shear stress for solid also, and it is the shear stress which has to be implemented for the hollow shaft also. So let us now try to compare the shear stresses for the hollow shaft and the solid shaft. So shear stress for solid shaft and shear stress for hollow shaft, hollow shaft, let us try to find out. Oh, there's no how to go about this. Okay. Now once you have done this, then the formula says it is T. So we can equate this to because it has to be the same. Now the shear stress for the hollow shaft and this has to be the same. We can equate this to. So we can equate this to, and therefore you can know that PR. So that the torque of solid shaft multiply. Okay, I'm using this equation. Radius of the solid shaft divided by Jp of the solid shaft is equal to the torque in the hollow shaft, the radius of the hollow shaft divided by Jp of the hollow shaft. Okay. Now as per the problem, it is said that the power and speed are same, so therefore the torque has to be same. So these two will cancel out. So this torque S and torque H will cancel out, and here radius will not cancel out, and this Jp will not cancel out. So here we can now equate these two. Jp of this solid shaft, so we can actually take this. So R of solid shaft can be written as D by 2. Jp of solid shaft can be written as P by 32 into D to the power of 4. D to the power of 4, and here, so RH of this hollow shaft can be written as D0 divided by 2, and this Jp of hollow shaft can be written as P by 32 D0 to the power of 4 minus Di to the power of 4. But here it is said that D0 is 1.4 times Di. So let us substitute this here. So when I substitute this here, so D0, so D0 by 2 y by 32. So d naught is 1.4 times di to the power of 4. Guys, I think many people make a mistake here. So it is d naught to the power of 4. So it is 1.2, so 1.4 di all to the power of 4. Okay, minus di to the power of 4. Minus di to the power of 4. Okay, so guys, so can you equate this? So you can understand that here this pi by 32 would cancel out, and what you're left with this, of course, this 2 and 2 will cancel out. So what is left is d is equal to, so d divided by
1 by d cube.
Okay, it is 1 by d cube. So you can say that it is 1 by d cube. So this and this cube gets cancelled out. It is left with, so d naught by 2. So of course that 2 has got cancelled out. Divided by how much? 1.4 raised to the power of 4 is how much? Here, this. How much? 3.8416 d naught to the power of 4 minus di, sorry, this is di to the power of 4 minus di to the power of 4. So what is the value now? So it is now, it is like, I can write it as 1 di to the power of 4 basically. So this can be written as 1 di to the power of 4. So this becomes d naught divided by 2.8416 d to the power of 4.
So you can convert that d naught into di.
So you can convert that d naught also into di, which is actually how much? So 1.4 di. So how much this becomes now? This di will cancel out. It becomes d cube. And then, so you can invert this, you can flip this, you can actually, you can flip this equation. So you can actually flip numerator to denominator. So flip numerator and denominator. Flip this denominator to numerator on both sides. I think it's same, no? 2 by 4 is equal to 1 by 2. You can flip it like it becomes 4 by 2 is equal to 2 by 1. It is the same thing. So you can flip this. So it becomes d cube is equal to
2.8416.
So 2.8416 d.
Di cube
So di cube
by 1.4.
divided by 1.4. What is this value now?
2.02.
2.02
2.02
di cube.
Therefore d equals to
So therefore d equals to
1.26.
1.26. So cube root of this, that is equal to how much?
1.26.
1.26 d di. Okay. Now we have got this. So we are supposed to find mass of solid shaft to mass of hollow shaft. So we have all done this. So let me erase. So here's mass of solid shaft to mass of hollow shaft. Mass of solid shaft divided by mass of hollow shaft. Mass of hollow shaft. Okay. So mass of solid shaft, basically, I mean, because the length is same, so we are actually calculating per length. So we should know the area. Area multiplied by length will give you volume. Volume multiplied by density will give you mass. Okay. So here, so if you want the mass here, so mass is nothing but volume multiplied by density. Volume multiplied by density for solid shaft divided by volume of hollow shaft multiplied by density of hollow shaft. Okay, but since it is same material, so density is same. So this will cancel out. So basically you are looking at volume. So volume is nothing but basically cross-sectional area. So cross-sectional area of solid shaft multiplied by length divided by the cross-sectional area of hollow shaft multiplied by length. But here it says length is also same. So length also cancels out. So here you got the cross-sectional area of the solid shaft. Here you got MS by MH. MS by MH, cross-sectional area of the solid shaft. So solid shaft, you can actually call it as, so D is equal to 1.26 di. So 1.26 di. So area is also what? Area is what? Pi d square by 4. So pi d square by 4. Here it is pi d naught. So it is pi d square by 4. It is pi d naught square by 4 minus di square by 4. Otherwise you can actually make this di square to the power of 4. Okay. So here you can again say pi by 4 and pi by 4, they cancel out. So what is left is d square divided by d naught square minus di square. So here, so let us now substitute here. So d ms by ms is equal to d square. So d is nothing but here 1.266. So d is 1.26 di to the power of square. Here d naught, it is said that it is 1.4 di. 1.4 di. 1.4 di square minus di square. Minus di square. So much is this. So this is, guys, please be careful. This is whole to the power of square here. I think this is basically like trying to combine your engineering knowledge plus your school and PU mathematics skills. If you struggled in mathematics earlier, then you will find it little cumbersome. Otherwise, this is simply playing with equations. That's it. So 1.26 raised squared is how much, man? 1.26 squared is how much? This one. 1.5876 di square. So 1.4 square. 1.96 di square, and this is di square. So this is 1.5876 di square divided minus this becomes 0.96 di square. So this di square square gets cancelled. So 1.586 divided by 0.96 is equal to 1.65. So which means that for the same material and for now to transmit same torque, now mass of the solid shaft, so this is basically mass of the solid shaft. Mass of the solid shaft to this is 1.65, which means that here mass of the solid shaft will be 1.65 times the mass of the hollow shaft. suppose if the hollow shaft was 1 kg, suppose if the hollow shaft was 1 kg, solid shaft would be 1.65 kgs. So, which do you prefer, solid or hollow? Hollow, because solid shafts will weigh more. Okay, so therefore, we have found this as 1.65.